Hello, and welcome to State of the Earth, the podcast from the Graduate School of Environment and Sustainability at the University of Exeter. I'm Daniel, an MSc student studying Marine Environmental Management. Today, I'm interviewing Professor Karen Hudson-Edwards, who is a Professor of Sustainable Mining at the Environment and Sustainability Institute and Camborne School of Mines at the University of Exeter. Karen's research focuses on the environmental impacts of mining and sustainable mining practices. She has been based at the University of Exeter since 2017. Thank you so much for joining us, Karen.
Oh, great pleasure. Nice to be here. Thank you, Daniel.
So, to start off with, then, I'd like to ask a broad question. Why is mining important in the modern world?
That's a great question. And I know there are quite a few people that don't like mining, so it's really important to think about why we have mining and need mining. And in fact, mining has been around ever since humankind has been around and picked up stone tools and so on to use. Today, we need mining because everything that we can't grow, we have to mine to support our lifestyles. So the computers we're using at the moment require materials that we extract from the earth. The buildings that we're in, the cars that we drive, and so on and so on. All of these need earth materials. And it's true that we can recycle some of what we need, but the fact is we don't have enough in circulation at the moment for many things to recycle enough. So mining is the way that we get these materials from the earth, and it's very important for the basic materials, but even more important now because we are going through the green transition in the quest for net zero carbon emissions to combat climate change. And so we need to mine the specialist materials that we need for our green technologies. So we need to mine lithium, cobalt for batteries, rare earth elements for wind turbines, and a number of other specialist metals often called critical metals, but also the basic things that we've always been mining, like iron and aluminium for steel and so on. So still very, very important in our modern world.
Absolutely, and I think you've touched on quite a breadth of products that we all interact with in our day-to-day lives there, that are reliant on mining. You mentioned a bit about the green transition, and the need for new technology. What role does mining play in supporting these industries?
Well, mining is aiming to provide the raw materials that we need for these green technologies. And it's true that we've mined many of these before. It's not that we haven't mined lithium, we haven't mined rare earth elements. It's just the demand for these particular elements, metals, and materials is rising exponentially as we start to use more of these technologies. So, for example, there's a big move, as we know, to move from petrol cars to battery-driven electric cars. And that demand is increasing all over the world. And so we need even more lithium and cobalt for the batteries. But we need more steel, of course, as well. And again, we're trying to get more wind power generated, both on land and off land. And again, we need these specialist materials that we haven't mined so much before in all these green technologies. So it's the rise in demand that we're seeing for many of these metals, these critical minerals and metals, that's really bringing mining to the fore at the moment that maybe people haven't thought about it too much before.
Thank you. Yeah. Also, you've mentioned just there the rising demand, which is probably only going to keep growing for the foreseeable future. Do you think that mining currently is in a position to meet that rising demand, to continue to meet it for the next couple of years or couple of decades even?
That's really a great question. So for some elements, it really depends on the element or metal that you're looking for. For some of those, yes, we're very good positioned to meet that demand. If I go back to iron, which isn't a critical material, but of course we use it so much, I think we're very good in terms of meeting iron demand. But things like lithium and particularly copper, actually, the forecasts are that we really have to work hard to try and meet those demands. So what's happening is the mining industry is responding to that by sort of increasing what we call exploration. So looking for new deposits, upgrading maybe old deposits and doing more exploration around those to try and get more mines online to meet that demand. But the thing about the mining industry is it isn't a quick process to develop a mine. There's lots of factors to consider. And the average length of time it takes to develop a mine, from starting to look for one to actually producing material, is between, excuse me, 15 and 20 years. So it's a long process, and governments are really trying to help with that, to try and provide incentives for mining to meet the demand, and to try and maybe help with some of the regulations around that, to keep them strict, but to make sure that we can meet this demand in the future. But alongside that, just to mention, mining is important, but also the recycling side. So we're involved in a project, and many of the mining industry companies are involved in thinking about circular economy. And that's thinking about part of it, not all of it, is thinking about getting the product from the ground, but also making sure it stays in circulation. So there's a hope that, you know, we will need mining. We will always need mining at some level, but we're hoping that for many of the things we mine, we'll be able to start to regenerate, reuse, recycle the materials that are mined, and we keep them in circulation. So that will start to meet some of the demand, we hope, for some of these metals, as long as we can do that effectively.
Thank you. Yeah, it's really interesting to hear about this sort of the interplay between mining and the recycling element there. So obviously mining, as you've explained, has a huge role to play in the green transition and in moving towards new clean energy industries. What issues will mining itself have to address to play a role in a more sustainable future?
That's a great question. And the mining industry is facing some of those issues now, many of them. And a lot of it comes from mining's past. So there's a legacy of contamination, pollution left over from mining in the past, and even today in some places. And that's because the mining industry, well, the world generally hasn't been aware of the effects that mining and other industry can have on our wider environment. So our soils, our water, our air. And it's only in the last probably 50 years that legislation has come around that and more recognition. So that's one side of it. The mining industry needs to be more responsible about not generating contamination and pollution, but also they need to and they are, I should say, they are thinking about being more responsible with people as well. So we know in our past, our mining past, that the safety around mines hasn't been good. People have been exploited in many ways, through working in very bad conditions, to companies coming into a country or area and taking all the wealth out of that for their own use and not leaving anything behind. There's also a big role in the broader, what we call community. So thinking about people, but thinking about mining areas. And you've probably heard, or we've probably heard of the term ghost town. And in many areas in the past, mines have come in, they've generated great wealth, they've employed people, and there's been prosperity. But when the mine closes, everything just stops and the towns can empty out and be left behind. So it's really addressing many of these issues in the past, again, some of which still exist today. And so the mining industry is really having a big drive towards sustainable mining, which is my job title, and some people prefer the word responsible mining. They are very much similar things. So this means still generating profits, because it is a business, but then thinking about being sustainable in mining. So protecting the environment, protecting human rights and human health, practicing safe practices, thinking about communities and the long-term role that mining will have in areas. So if a mine is going to start, that's great, but planning from the beginning to ensure that if the mine closes, which eventually they will do, what is left behind, and engaging with communities to do that. So it's been a really exciting time. I've been in this area of work for many years, and I think we're doing the industry, and we're helping in academia to make the industry move towards this sustainability and responsibility. So it's a very exciting time to be working in this area.
It certainly sounds like it. And thank you for touching on both the environmental sustainability, but also the social sustainability element of mining. I think clearly both of those are immense importance. So focusing on the environmental sustainability side just for the moment, could you talk us through some of what sort of waste products might come out of mining and maybe what can be done to limit those waste products or to mitigate their impacts?
Good, great question. So at the mine site itself, there is a localized, if we start with the gas, so I'm a geochemist, so I think about sort of solids, liquids, and gases. So if we start with the gas, of course, most industries will generate carbon dioxide and carbon-based gases. So they are greenhouse gas emitters. And that comes from most of the activities that happen at a mine site. So that includes trucks driving around to the side of what we call minerals processing. So in mining, there's the extraction side. So that's where you either go on a surface, a big hole in the ground, or you go underground and you get the rock out and you bring it to an area where it's processed. And the first part of processing is something called comminution, which basically means crushing the rock. So you crush it down to different sizes and ultimately to fine grain sizes so that you can extract what you want out of it. It's much easier. And that uses a lot of energy. In fact, that's the most energy intensive part of the mining and extraction or processing sequence. And then once that happens, depending on which ore or metal you're trying to find, it goes on to further processing. And that can involve essentially burning the material. So that's called pyrometallurgy or smelting. And that drives off gases, other gases like sulfur dioxide. And so you can see acid rain because that sulfur dioxide gets into the atmosphere. It combines with water to produce sulfuric acid, which is acid rain. So the two main gases we see around mining areas themselves are carbon dioxide, carbon-based gases, and sulfur dioxide. What is being done about that is the industry is very much looking at its carbon budgets, trying to reduce those wherever possible, even becoming carbon neutral. So driving electric trucks, thinking about different ways to crush materials and extract the ores, and also putting what we call scrubbers on chimney stacks so that the sulfur dioxide doesn't escape. So that's been going for many, many years. If we think about the water side, so mining can generate, well, sorry, I should say water is used in the mining process in many, many ways. One of them simply is if you're in a big mining area, you'll often see really large trucks driving around spraying water on the ground. And that's to keep the dust down because we know dust is actually a pollutant as well. We don't want too much dust getting in the atmosphere because that plays with our respiratory systems. But water is used in the processing. So a lot of processing of the ores takes place using water and acids and so on. And also water underground to keep things cool and so on. But the waters can become polluted in many ways. One is with some of the chemicals that are used in processing, but also by reaction with some of the materials from the earth as well. So some of the materials that we take out, and specifically our ores, contain minerals that can react with the water, so the waters that are used in processing, but also rainwater if these materials are left as waste. So waste is a big problem for the mining industry. And just as a sideline, if you think about it, these days we are mining copper ores with very low grades, so less than 1% copper in a rock. So that means you take out a kilogram of rock and only 1% of that is copper and the rest is waste. So waste is a big thing to deal with, and it's often piled around mine sites or stored in impoundments called tailings dams. And so those wastes can interact with rainwater and groundwater and so on, and they can generate different types of waters that we call mine wastewaters. And the worst one of those is acidic. So if it reacts with a particular mineral, it can produce acid, and that's definitely what we don't want in our environment. And if you look around many legacy, what we call historic mine sites, where they haven't been managed properly, you will often find these wastewaters. And if you have acidic ones, you can tell that they're probably these acid waters. They're called acid mine drainage because they're rich in iron and they orange to red, very distinctive. And they can be quite bad for the environment because if you get acid into normal soils, it will destroy the ecosystem or reduce the biodiversity. It could contaminate soils and so on. So that's a big, big issue. And then finally, the solid waste. So there's the waste left over from processing. There are different types of that. Tailings is one of them. It's really fine-grained material left over after you process. So normally these days it's stored in dammed impoundments, but unfortunately these impoundments can fail sometimes. So you hear about things called tailings dam or tailings storage facility failures. And they're very devastating because these tailings in the past mostly have been stored wet. And so if the dam wall breaks, you get a wet wave of slurry going very fast, usually down a river system and causing a lot of damage and sometimes deaths as well. And these tailings can be polluting and contaminating as well because they contain all the waste elements that we don't want. And often these can be very toxic, like arsenic and cadmium. So those are the main types of waste. We can also produce a waste called slag. So that's the material left over after we burn the ores. It's like glass, like a little bit like lava if you've ever been to Hawaii. They don't produce much of it, but in some cases there is quite a lot. And again, that's another waste that can contain all of these elements. So there's a lot to deal with, in terms of all these different types of contaminants. Unfortunately, these days, as the mining industry moves towards sustainability, we understand not all of them, but a lot of the impacts these wastes can have. And so there's a lot of regulation around understanding your waste even before you produce it and putting in mitigating ways to stop it from being generated. So not producing acid water, controlling your solid waste so it is contained and not getting into the wider environment.
Thank you for talking us through that. So there's clearly a wide variety of waste issues that need to be addressed and that are key issues for mining and for the mining industry. You touched in one of the previous questions a little on the long history of mining. Do we still have an issue with some of the legacy of that mining in terms of waste? Is that still posing an issue for us today?
Absolutely, absolutely. So yes, not only do we have to sort of think about our new mines that are many of which are looking quite nice now, but you're absolutely right. There's a huge legacy. Every country in the world, except probably, well, Antarctica isn't a country, but everywhere there's been mining, there is a legacy of mine waste in some way. Sometimes we know where it is, sometimes we don't. But yes, it's a huge issue and it's been unmanaged. So in many cases, it's not contained in a small area, it's dispersed widely. So one example is I participated in a paper that came out last year looking at the impacts of mining broadly in the past on river systems. And we showed that many river systems around the world have been impacted by mining. And you wouldn't think that because you think the mining is concentrated in a particular area. But in the past, when we didn't have containment for wastes, a lot of the waste were thrown into rivers because they thought, oh, that's just a great way to get rid of it. Let's just throw it away. We don't need to think about it. And as a result, rivers and oceans and estuaries have become contaminated. And again, with the way in the past, we've always been smelting ores. I mean, ores have been smelted since antiquity with no regulations about containment of gases or pollutants. And so you can often see a area around the old mining areas where the airborne pollutants have affected to some degree the area around. So the legacy waste is a huge issue, absolutely right. Some countries have enough money to deal with that. So some countries are able to go in and map where their legacy waste is and work to make it inert and not harmful for people. But a positive thing that's happening with old waste of different ages is coming back to the circular economy and re-mining, recycling, whichever you want to use, and trying to think about waste in a different way and think about it as a potential resource. So We know we need a lot of these metals moving forward for our green transition. And many of these are contained in the old waste because either the mining technique wasn't very efficient, so they weren't extracted, or we didn't care about them. So maybe lithium wasn't interesting, cobalt wasn't interesting at the time, so that might still be in the waste. So there is quite a lot of effort going on to explore the waste, just as we might explore for a brand new rock deposit. That's been really gaining traction over the last few years. And it's not to say that all wastes are amenable to this, but there are places where waste is actually being mined, which is very exciting. And hopefully that will deal with at least some of our legacy waste issue.
That certainly sounds like a positive, going back and reusing at least some of these legacy wastes. You've mentioned a little bit about the widespread nature of areas that are affected by mine wastes and have been affected by them in the past. You mentioned the study that you were involved with that was published last year. I think the top line findings, if I'm remembering correctly, were that almost 480,000 kilometers of rivers and about 165,000 square kilometers of floodplains were affected by metal mines.
That's right.
If I'm getting that right. So I suppose what I'm building towards really here is, does the mining industry have the capacity to address waste on such a widespread scale? That's such a vast area.
It's massive, yeah. And that's a good question about does the mining industry have responsibility? That's a good question. It depends on which country. I'll start with that, which country you're in. And so mining industry, if you gain the rights to explore an area, there are some places where you are required to deal with the waste, or you might want to anyway, just so that the area is clean. In many cases, though, the companies that were responsible for generating the waste don't exist because, these are hundreds of years old. So often it's left to governments to deal with the waste. So you're right. It needs to be dealt with by somebody. I agree. So my colleagues that we published the Rivers paper with have discussed this many times. And because the waste is just, in that particular environment, in many environments, it's just so widespread. And in rivers in particular, where it's in the floodplain, and we know that many rivers are active systems. So that floodplain material may be there for a while, but it might get eroded, might get redeposited downstream. So if you were to do something, it might not last for very long. So I think in some cases you can remediate, or you can remine or recycle. But in some cases, it's more a case of managing the waste, especially in river systems. So if you can identify hotspots that are really, and also causing known harm to animals and people and so on, those are the things that really have to be dealt with immediately. In the long term, I think it's managing. So it's knowing where the waste is. It's understanding what it is, so what we call characterizing the waste. What are the metals or the elements in there that are particularly able to cause toxicity. Let's keep an eye on things. Let's monitor how that area changes. Let's do hopefully some studies to see if there's any impacts on people and animals. And let's just understand the system and keep an eye and monitor. And if things change, then that's time for intervention. And I think it kind of has to be that way because governments all over the world, well, we know in Britain, our government is new, but finances are tight and there's not a lot of money to deal with every single legacy waste site. So there is a lot of effort going on and to monitor and map these systems. Our Environment Agency here in the UK is responsible for looking at the areas affected by metal mining, and they do exactly that. So they understand where things are, they're monitoring, and they're intervening where necessary. So it's a good move, and I think what would be nice is if there was some global harmonization about how we deal with these things, and agreements about what we can do and what's important. And that's particularly important if I come back to rivers, because rivers don't care about international borders. They cross them often. So if there's cooperation to think about these things, and I think that's a great way forward.
Cooperation certainly sounds like a positive to have in all of this, and certainly international cooperation as well. So thank you for touching on explaining the global nature and the cross-boundary nature of mining and mining related issues. Moving back towards the development of sustainable mining and the need for mining in the future, where in the world is mining going to be important over the next couple of decades?
Great question. So that's a good question. I think a lot of countries that at least had a mining industry, and even those that haven't, are looking again because of the importance of critical metals and the need and potential, well, profit to be made from mining these things. Again, it's a business. So even here in Britain, we're starting to explore again, and there are new mines, I hope, coming on stream. So we thought our mining in Britain was finished. In Europe, again, some places are looking. The big players, I think, are going to be Chile. And Chile, one of the biggest things that people are looking for is copper, because copper is a critical metal named by many areas, and it's needed for wiring. So we know that we need it in almost everything we do. And Chile and to some extent, sorry, Peru as well, especially Chile, have the biggest copper deposits in the world. And there's some of which are already being mined, but a lot of work going on to find new copper deposits because there is a lot of demand for copper. Australia is a big mining nation. I think we'll see that continue. Lots of big iron ore deposits there. So China as well is going to probably keep mining. If you look at the global distribution of critical metals, so there's a number of these, China is very wealthy in terms of these critical metals. So they not only do they have the mines, but they have very good understanding and ability to do the minerals processing side. So not only will they get mines for themselves, but they're able to extract the metals as well. So China is a big player in this area. Countries in Africa as well. So Zambia and the Congo, some of the Central African countries have very good mineral wealth, and particularly again in critical metals. So I'd say, yeah, probably Chile, China, Central Africa, Australia are the biggest players, but keep an eye. I mean, most countries have exploration activity going on at the moment. That doesn't mean it's going to go to a mine eventually. There's so many factors to take into account. The metal price, which can go up and down despite the demand. The social and environmental impact of potential mines. You know, if a company can't fulfill the requirements that a government will set out, then it's very unlikely they're going to get to mine. And also the money side. To get to a mine over that average of 20 years or more or less needs a lot of investment. And so trying to get the funding to keep going to actually get to mine is a massive factor as well. But it's looking good, and new mines are opening as we speak to try and fulfill the demand.
I suppose, as in all things, money is what makes mining go around, as it makes the world go around. So I thank you for sort of touching on the global breadth of mining and the importance to countries across the world. Thinking a little closer to home, then, is there a role for mining in Cornwall? Again, Cornwall having had such a great history of mining, but perhaps not for some time now. Do you think that this is an industry that could develop here in Cornwall again?
Yes, is the answer. So you're right. The last metal mine, so closed in 1998. That was at South Crofty. We still have mine in Cornwall, actually. It's been going for almost 200 years, and it's the clay mining that happens around the town of St. Austell. So that's actually still going. They've reduced their workforce so much, but they still produce clay, kaolinite, and things for ceramics and other things. So, but in terms of metal mining and the critical minerals and metals side, there's great potential in Cornwall. And I think that's because when mining ceased in 1998, but actually most of the mining had ceased by the early 1900s around then. The main things that were being mined were copper and tin, and the tin price really crashed actually in the 1980s. But there was less demand for tin from Cornwall because other places had found tin. And likewise, copper, we had good copper deposits, but some of the bigger deposits around the world were being mined. So the mines ceased operation, not because there wasn't anything left, but there was just different players involved. And again, the economics weren't favorable. But now we're very excited in Cornwall. So there's 3 critical minerals, or 4 actually, sorry, that have great potential. So one of them is lithium. We have tin still, that's critical metal, copper to some degree, and we have tungsten as well. So the geology of Cornwall is such that we're very well endowed with these particular minerals and others in smaller amounts. And since 2016, there have been, I think it's 8 companies doing exploration for one or more of these metals. So Cornish Lithium kicked things off in 2016, and they have a very interesting story. So they raised some money to get going on the back of a report. I think it was from what was the British Geological Survey in the late 1800s, where one of the geologists had been underground in one of the deep mines with some of the miners looking at the hot waters that were pouring out of the walls. It's very wet, as you would imagine, in underground mines in Cornwall. And he analyzed these for lithium, interestingly, even though lithium, I think it was used at the time for people with schizophrenia, but wasn't really a commodity that people were interested in. But however, he analyzed for lithium and made a report that you can still find this today that said, if there was a big use for lithium, this could be a mine. So on the back of that, Cornish Lithium raised some capital and they started exploring for geothermal lithium. So this is lithium beneath the ground in the hot waters underground. And that really sort of started things off again, I believe. So they've been exploring ever since. They've been still looking for geothermal lithium. Now they're looking for lithium in what we call the hard rock, so the rock itself. And since then, other companies have come around. So we've got Cornish Metals, Cornish Tin, Cornwall Resources, who else? And a few others. And they're looking for tin, tungsten, the Hemerden mine, Tungsten West, rather, just into Devon. And many of these the exploration is suggesting that, again, we do have really world-class deposits, particularly of tin. So I think my opinion, and I think the opinion of some of these companies, is that yes, mines could come back to Cornwall. We have great support from the university and from the local government and the federal government as well, who's published a critical mineral strategy. And we hope, yes, I think there's talk that certainly some lithium mining could happen and eventually tin mining as well. And tin is also a critical metal because it's used in solder and among other things, but that's its main use. So again, we use that for many, many things. So the lithium looks good and could supply a lot of the lithium that we need in the UK. And the tin in particular, these are world-class deposits. So they're on par with some of the big global players. Looking really positive, and there's the local companies are growing. So they started small, they're growing, and they're hiring graduates from the Camborne School of Mines, hiring local people, really engaging with the communities and really thinking about the environment and sustainability. So it's really exciting place to be. Again, exciting to be in mining in general, but exciting to be in Cornwall in particular.
Yeah, there's clearly some optimism there for Cornwall and both for environmentally and socially sustainable mining to develop here again and be integral to local communities once more. So you touched then on students from Camborne School of Mines from the University of Exeter going to work in mining in Cornwall. What is the University of Exeter doing to support the sustainable development of mining, both in Cornwall and on a global scale?
So yes, briefly, they supply support for us at the Camborne School of Mines to train people working all across what we call the mining value chain, from exploration to minerals processing. They're supporting our research projects, so there's quite a bit of funding around at the moment to look at mining not in Cornwall and outside of Cornwall, and thinking about sustainable development and mining, and working with the mining industry, and also just examining what they're doing and working with them to try and keep the move to sustainable mining going very well. They also support us with helping to host in-person and online meetings where we get different people in to discuss ideas. So I'd say the university is very, very supportive. That we have good global networks as well. We have a relationship with the University of Queensland called QUEX, and we have a specific mineral security and sustainability theme in that, which is funded by both universities. So it's great. They've been very helpful, and we're really pleased that the Camborne School of Mines is part of the university. Absolutely right.
Thank you so much, Karen. It's been great talking to you. And you can find out more about the University of Exeter and its academics work on our website. Thank you.
Thank you.
Thank you, Karen. Sorry, it was